Hey everyone, this is Iman, and today I want to talk about something really important: how buildings perform after earthquakes and what we can do to improve that. National Institute of Standards and Technology, NIST, recently published research on functional recovery. And I am going to break down an infographic that highlights the key issues. All right, let's get started. All right, so current American building codes follow something called life safety design. This is all about making sure buildings don't collapse during an earthquake. And that's super important because it saves lives. But here's the thing. These codes don't really focus on what happens after the earthquake. How long does it take to get back to work? How long before schools open again? That's where the problem lies. In this infographic, NIST points out that while current codes do a great job at preventing collapse, they do not address the loss of building functions or how long it takes for communities to recover after a disaster. And when you look at this on a larger scale, the effects are huge. Jobs are lost, schools stay closed, and entire communities can be displaced, right? Okay, now let's take a closer look at the infographic. First, we have life safety design, which is what we use now. Before the earthquake, the building is fine and functioning normally. Then the earthquake hits, the building survives, it doesn't collapse, but you've got moderate damage, cracked walls, broken windows, and fallen items. It's not safe to use anymore, so everyone has to leave. And then next comes to repair planning phase. This is when engineers inspect the damage, draw up plans, and you wait for permits and contractors. This process obviously takes time, right? And finally, we have ongoing repairs. This can take, months or even years. And during that time, the building stays closed. Businesses shut down, schools cannot reopen, and the community basically struggles to bounce back. Now, let's compare that to functional recovery design, which NIST is advocating for. This is about designing buildings not just to survive, but to recover quickly. Before the earthquake, the building is designed to handle shaking better, so it's less likely to take heavy damage. After the earthquake, there's only minor damage, a few cracks or scuffs, but nothing major. Repairs are quick and don't disrupt the building's use. Okay? And the key here is the functional recovery phase. As you can see, within 2 months, the building is usable again. Businesses reopen, schools are back in session, and life starts returning to normal. And over time, you get to full recovery. But the point is that life doesn't stop while you wait. Now, this idea isn't just theoretical. Recently, a draft of Volume 8 from the FEMA P-58 series, also known as ATC 138-3, was published, specifically focusing on functional recovery. Okay? And looking ahead, the next generation of performance-based seismic design will be centered around functional recovery. This concept has already been proposed in the 2026 NIHR provisions, and apparently functional recovery-based design is now on the agenda for the ASCE 7-28 committee. So what's the takeaway here? With life safety design, buildings save lives, but they might be unusable for a long time. With functional recovery design, the focus is on minimizing downtime, so communities can recover faster. And it's not just about surviving earthquakes, it's about keeping life going afterward. All right, that's it for today. If you found this helpful, please subscribe and like if you want to support the channel. Thanks for watching.